So far, trigonometry's only worked on right triangles, but now we're going to go ahead and figure out how can we use it for non-right triangles. So there's kind of particular situations where you can use it on non-right triangles, and one of those situations is the law of sine. So it kind of depends upon what you're given and which situation is going to work. We'll go over the difference after we cover law of sines and law of cosines. I think we probably should somewhere in there. So usually the way law of sines I do know works is if you have the angle, notice big B and little b, how they're across from each other. As long as you have two pairs, like big B and little b, you have those, and maybe big C and you're trying to find little c, then you can use law of sines, that kind of situation. But obviously, before we go over that, you got to use it first. Now, how is it that this works? Well, I'm not going to derive the whole thing, but it comes from, it's pretty cool, if we split this into two right triangles, then that's where we're able to come up with this formula for law of sines. And we can go through those details a different time, come to tutoring or something if you need to do that. For now, in this video, I really just want to go over how do we use it. So notice this law of sines, little a over sine of big A, little b over sine of big B. And that's the important part, little c over sine of big C. And realize little b and big B, those are across from each other. So the angle and sides across from each other are how we're going to create our ratios. Notice the angle goes inside the trig function like it usually does, and then the side's going to go on top. I think it could go on bottom because it's going to be the same thing, still going to be an equivalent ratio, which is fine, but this particular example shows where the sides are on the top, and that's what we'll go ahead and do. So find AB. AB is this side here, so I'll call that X. So what are we going to do? Well, you saw earlier, look at this. We could put this side over the sine of this angle, and that'll equal this side over sine of that angle. That's what this is saying. You could take this side over sine of that angle and set it equal to any other side you want to, as long as you put it over sine of its angle that's opposite of it. So let's go ahead and do this one. So I'm going to do 8 over sine of 122. Notice we're in degrees. And that's going to equal x over sine of 26. Cross multiply to get x times sine of 122 equals 8 times sine of 26. I almost said 126. Then we're going to go ahead and divide all that sine of 122 to the other side. I guess I should have shown that process, but I think you can kind of fill in those blanks. And then you just put that in the calculator. Don't be simplifying 26 over 122 or any of that. You can't mess with it because it's in the trig function. And that's going to be 4.13. They want the nearest tenth, so 4.1. And there you have it. That's law of sines. Pretty simple. Let me go ahead and set this up and then see if I can find one. Hopefully I got one here. I don't think I did. Well, there's one with the angle, so we definitely need to go over the angle case. I wanted to go over what if it was this side we needed to find. I know, let me just go ahead and change those instructions. Let's just say they wanted us to find BC. This is our X, right? That's what we need to find. We don't have the angle across from it. But if we have two angles, we know they all add up to 180, don't we? So we can do add up the 67 plus 33, which is 100. And so 67 plus 33 is 100. Take that away from 180. And that gives you this angle. So if you don't have the angle across from it, you can always find it. As long as you have two of the three angles, you can find that missing angle. From there, I'm just going to set it up. I'm not going to solve it. So here we're going to do 5 over sine of 33. And then 80, or no, not 80. See, I'm messing up. X over sine of 80. So I did x over sine of 80. So that would go ahead and work. 5 over sine of 33 equals x over sine of 80. And then you just cross multiply, solve for x. Let me go ahead and do the missing angle. So this one, we have a missing angle. So you're going to need the side across from it. This one has to have the side across from it. unlike the other one, because if you have two of the angles, you can find the third. But if you only have one angle, there's no way we can just guess one of the other two angles. So we're kind of stuck here. So you need to make sure if you're the given angle, in order to be able to use law of sines, that given angle, you have to have the side across from it. So let's set this up. A is what we're looking for. So we're going to do 9 over sine of 63 equals 6 over sine of x. Cross multiply. Now check this out. X is stuck inside of the trig function, right? So let's go ahead and divide the 9 and get the trig function all by itself. And we could actually simplify that. Now, how do we get x by itself? Do you remember if x is stuck inside the trig function, we just do the inverse of both sides. You can refer to one of those previous lessons from the last unit. That was case 3 of solving for the angle, right? When we solve for an angle, we have to do an inverse trig function, and there we are. We're using the inverse trig function because we're solving for the angle. See, I told you that last unit was definitely foundational. And then from there, it's going to be kind of gnarly plugging this into the calculator. So sine inverse of 2 sine 63 divided by 3. And then they want us round to the nearest degree, actually, so that's 36 degrees. And that's law of sines.